I thought I'll talk a little bit about, well, I guess design is something that many of you are very heavily involved in, but perhaps not design for the mind. And so I decided to focus a little bit about that and talk about it in my presentation. First, I just wanted to talk a little bit about human factors because it is something that is becoming very prominent in the maritime industry, but there are different views of human factors and ergonomics and different approaches. So I just thought I'd mention the perspective I've taken, and that aligns with the International Ergonomics Association and Human Factors and Ergonomics Society. And they define firstly, they view human factors and ergonomics as the same thing. Ergonomics is more the European term, while human factors has a more American touch to it. But they are the same thing, and in this presentation, I'll treat them as the same thing. So they define human factors or ergonomics as the scientific discipline concerned with the understanding of interactions among humans and other elements of a system, and the profession that applies theory, principles, data, and methods to design in order to optimize human well-being and overall system performance. I think that definition has some important aspects to it that is worth mentioning, and that is mainly in contrast with, for example, the definition used by IMO, the International Maritime Organization. The Human Factors Society emphasize the focus on interactions. IMO talk about the human element, which mainly focuses on the human, the limitations and abilities of the human. But the scientific community more focus on interactions between humans and other parts of the system. So technologies, tools, techniques, methods, and whatever. And I think that makes a big difference because if we focus on the interactions, we can't ignore context. If we focus only on the human, like the IMO then I proposed, we kind of close a lot of the system out, and we focus only on mainly the shortcomings of the human rather than the abilities and the ability we have to actually improve the system as a whole. Typically, human factors focus on 3 different domains, and the most common we talk about is probably the physical factors, traditionally what we associate maybe with the term ergonomics, how well a physical artifact fit with the human, maybe a chair or something. But human factors is also very much focused on cognitive aspects of the relationship between humans and other things, such as perception, attention, memory, workload, and those kind of things. And also organizational factors, which is very much what my research was focused on: teamwork, hierarchy, coordination between people and other parts of the system. And all of these ones are then the human factors and ergonomics, the main domains. And for human factors to be interesting, we need not only humans, not only a social system, not only technology, not only a technical system, but a socio-technical system. That is when human factors become interesting. And you see there in the slide, we have humans, of course, of all different forms and shapes and sizes and ethnicities, cultural backgrounds, abilities, disabilities, and so on. And then we have the technical components, which is probably, when we think technical today, we think about maybe big mechanical pieces of engineering, but technical here means maybe more the traditional term technique, which has to do with any kind of technique or tool, such as a checklist or whatever we use. A structure, an organizational structure, can also be viewed as a technology to get things done, to shape how things are getting done. the use of colors to indicate this and that to communicate, or the information in a system. A social technical system is then when we take the whole as our unit for analysis. We don't only focus on the social aspect, the human, or the technical aspects, the piece of technology or the tool. Social technical system is when we take a holistic perspective and view them all as one and as important. Just an example from defense, because I understand there's a lot of defense people here. We can of course view HMAS Canberra as one piece of a technical system, but that has limitations, and reality only viewing it as a technical system is not going to take us all the way. We have to view it as a technical system as part of a larger social technical system where the vessel and its crew has to interact with other vessels. They have to deal with emergencies, unexpected situations, political agendas. They have to deal with society, as we can see there on Australia Day in Sydney Harbour. And they have to deal with me when they come to Sydney and want to participate in this event, for example. And that was a very interesting experience, because we have different perspectives, commercial shipping, like I'm involved in, and defense, Navy shipping, of course, different ways of doing things, and importantly, very different way of organizing work and organizing teams and people. So if we are interested in a system from a socio-technical perspective, how we can improve performance there, that's when we should use human factor principles and human factors methods. That's when they are most valuable. So I thought I'll talk a little bit about a few design considerations that I think are probably extremely important, but not often that much talked about. We can all find a human factors book and find some techniques and principles in it, but these are a few that I selected because in my research I saw that they were so prevalent and so common, and we didn't really realize it. And I was certainly not aware of the importance of these principles before I did the research. So that's why I selected to talk about them today. And I only have 3 principles here that I thought I'll discuss a little bit. And the first one, the difference between work as imagined and work as done. And some of you might recognize this is part of Eric Holnagel's work. And in socio-technical systems, of course, consist of technical components which we have designed ourselves. We have drawings for them. We know exactly how they work. The system is relatively stable over time. And if something goes wrong, we can actually fault find and identify the cause of it. But in a technical system, that is. But in a socio-technical system, it is not as that easy, because humans or societies or cultures doesn't really work that way. They constantly change. And we only partly know how they work. We usually discuss how the human work and how the human brain work by analogies and metaphors, because we simply don't know. We talk about mental models, we talk about situation awareness, but those are all metaphors that we use to describe something which none of us have ever seen, and we don't even know if they exist, even though they are very useful concepts. But the consequence of this is, in a socio-technical system, we simply don't know everything how it works. So there's always going to be a difference, a discrepancy between work as the regulators and designers and managers imagine it to be, and work as it is, as it actually happens. And failure to recognize this discrepancy leads to blame and applying techniques and methods to analyze systems that are probably not the most appropriate ones. In the left image there, This is how it worked in the 1950s, or maybe up until the 60s and 70s, a little bit in the production industry, where a lot of the work was actually predictable, stable over time, uh, properly supervised, and without a lot of the environmental factors that we experience today. Today, we are expected to multitask, to do more than most of us can probably cope with, to do well. And we are forced to make decisions under uncertainty and under pressure. So we need to recognize there is a significant difference between how work is imagined and how work is done. And the implication that has is, of course, that we can't take rules and procedures and plans as the truth. That is, they are useful, extremely useful, of course, but they are not going to take us all the way. Human performance is always going to be a little bit variable, and we have to recognize that. Second principle also comes from Eric Holnagel, and this is the acknowledgement that firstly, resources are always limited. Resources in terms of time, money, people, the willingness to put in effort, and so on. And because they are limited, we cannot be both efficient and thorough at the same time, although we wish we could, because efficiency implies the use of minimal resources, and thoroughness implies expending a lot of resources. Therefore, we must always make trade-offs, taking into account the current situation. Are we prioritizing safety and quality at the moment because maybe we have time and resources, or all of a sudden we have a new competitor and we increase our expectations on throughput and output instead? But we can't do that without shifting some of our resources from thoroughness to efficiency, for example. And we have to recognize that this is something that will take place whether we want to or not. And it's nice to say that we can both be safe and efficient at the same time. But safety and efficiency, or thoroughness and efficiency, are always going to be at odds with each other in some way. And because the system always change, socio-technical systems always change, and because our priorities always change, therefore, human performance must always change. So it's variable. I cannot see my notes when I'm presenting, so I'm just making it up now, but hope that works. Well, a consequence of this having to make these trade-offs is that we take shortcuts. We take shortcuts as long as we feel that we get the job done to the extent necessary. And usually these shortcuts works really well. And usually, or often, they are also maybe even expected from management and so on. It is only when the shortcut goes wrong that it is criticized. So we have to recognize that human performance variability is a necessity to make things work, because the system is so dynamic and fluid. But that variability is also, well, that is what we call, for example, human error when it goes wrong. So it is the same coin. Human variability is not something that we can just eliminate. We have to deal with it in socio-technical systems. And a third principle or consideration, which might be very, I don't know if it's talked very much in the technical domain, but redundancy is something that is used a lot to increase reliability and therefore safety. It is used a lot in our technical platforms as a strategy. It's a cheap way. Rather than buying more higher quality components, we buy several lower quality components, and that can often be the preferred way of doing things. And there's a lot of different ways of doing redundancies in a technical system. And I think the human factors community, in the start, we're a pretty young scientific discipline, but we were a little bit too keen on borrowing methods from other scientific disciplines in the start that didn't end up working as good as we thought, and redundancy is one of them that we borrowed straight from engineering and applied it on social technical system and social groups. But what we're starting to see now is that redundancy doesn't work at all in social systems, or is quite often actually dangerous in social systems. Partly because redundancy means having an extra component or an extra human that is not necessarily needed for the functioning of the system, but it provides a backup. But we know, for example, from the law of the stretched system, that we can have that person as a redundancy, as an extra resource for a while, but sooner or later, that resource will always be exploited elsewhere in the system. An extra person that stands next to someone else watching that person work or something, after a while that will be seen as an inefficiency, and that person will be used for other things, and all of a sudden that person is not ready to act as a redundancy when needed. That's one example. Another example of the effect of social redundancy is called the bystander effect. We know from a lot of studies and experience that in an emergency, for example, the more people that are witnessing the emergency, the less likely it is that anyone will actually interfere or call for help. This dilution of responsibility, when there's more people involved, we think that someone else will do it, or it doesn't matter if I don't do it, or we're afraid of actually taking the step forward. This is of course not a problem in technical systems, where we simply design the system for one component to enter under certain conditions. When if and or something condition is met, that component will independently just step in. Social systems doesn't work that way, because humans are always interdependent. What one person do affects everyone else, and vice versa. From the cartoon there, see someone lying on the floor, and a lot of people walking by, and there's been a lot of experiments done on this, where people are injured, and simply people don't help, and that's a kind of an effect that could be we could see in social redundancy systems. Another thing is, when we throw more people into working together, we always think that teams is the solution for everything, but teams come at a cost, coordination cost, the cost of coordination, the cost of getting everyone on the same page, the cost of communication, especially maybe if we're geographically distributed or from different cultural backgrounds. Those coordination costs are rarely taken into account because they are not cost in technical systems. More recently, of course, we applied the redundancy principle in social systems when it comes to autonomy. You see the picture there of a Uber autonomous car, of course, with a driver in the seat who was meant to be monitoring the autonomy and interfere as needed, but failed to do so because the person was, of course, doing something else. It's easy to blame that person. You should have monitored the system. You should have interfered when the system didn't function as expected. But it's been proven so many times over the decades that humans just don't work that way. So we can't use these principles in socio-technical systems the same way as we use them in technical systems. And that is something I think is really, really important, especially in technical domains, not to extrapolate methods from engineering onto socio-technical social systems, social technical systems. This is, for example, my research at AMC was, this was the conclusion of my research. I studied, for example, how ships come into Sydney Harbour, and the state of New South Wales mandate every ship to take a pilot, simply because of the reason that we don't trust all seafarers being as good as they could be. So we make it compulsory for them to use a pilot. And we started to see that there's a lot of problems with the relationship between the shipmaster and the pilot when it comes to communication and teamwork and so on. We also added a shore-based traffic controller to monitor the traffic. And all of a sudden, we have 3 people who now have to work together largely to complete the same task. So there's a lot of functional overlap here, which is a type of redundancy. And then we wonder why we have problems with communication and teamwork. My conclusion from my thesis is, to a large extent, this can be explained because of the principle of redundancy isn't as effective in social systems as in technical systems. Adding more people is not going to make you safer, not necessarily, at least. That's the 3 principles that I think are extremely important, but rarely discussed. I'd be happy to hear from you guys if this is something you reflected on, if it is relevant for your work at all. Do you use human factors principles at all? And if so, are these ones something that you have heard about before?
So, Joachim, you're saying that like humans are very unlikely to override a technical system, even if we believe it to be an error. Is that?
There is a risk because we are very bad at monitoring and choosing when to enter an activity. It's not that we don't want to. It's because firstly, we're bad at it. And secondly, because if we for a long time are exposed to being redundant, we are either taken by someone else to do something else, or we choose ourselves to do something else, which makes us even worse at monitoring and interfering.
Yeah, this is something that I kind of see happen. Yeah, I see this kind of happen in my work sometimes, you know, people trusting a computer program to calculate a number for them without using, without kind of thinking about what if the number is correct, and just spitting it out saying, you know, I put the right input in, the output should be correct.
Yeah, so the typical...
It's not always physical.
A typical solution then for a company would be to, well, we can't really trust the computer, so we ask the human to double check it. But that's when we become redundant again. And then we have those problems of the human when they're under stress. They say, oh, well, the computer already done it. I don't have time to double check it now. And we start to drift away from the benefits of redundancy. So if the social component is part of the system, it's probably better to invest in fewer but better quality parts.
Yeah, so how do you keep someone interested in double checking what a computer does?
Well, I think that's not, I think we're asking the wrong question in that case. We should probably not even ask a person to do that.
So Joachim, thank you very much for your talk. I'm using some of Professor Holnagel's work, especially around functional resonance analysis methodology, for looking at how, particularly how we maintain work, how work is done on the maintenance of vessels, and the variability that we have in how maintenance tasks are done, repetitive maintenance tasks are done, but also how corrective tasks are done. And so two things. It's great to hear someone talking about Professor Holnagel and his application of the work. And the difference between work as imagined and work as done. what we've been sort of talking about in human, some of the work that we're doing around well-being is understanding the work pressures that we put people under and how they respond to, say, if we've got a one full-time equivalent and we're asking someone to do a scope of work that is, say, 1.25 a full-time equivalent, how we deal with increased intensity or increased duration in how that work is done. Did you come across any of that work, any of those issues in your work about teamwork?
I'm not sure I exactly understand what you mean in terms of understanding the work pressures and how they change. Is that?
Yeah.
Yes,
yeah.
Of course. And that was actually that's a very good point, because it's not always easy to predict how they will change. So we throw in the whole arsenal of people just because we don't know if they will be needed or not. And then we end up, for example, we have cruise ships coming in to Sydney Harbor, which are extremely maneuverable. This research, it was a couple of years ago, so things have changed now, but then we threw 3 tugboats on them. And of course, they weren't needed.
Yeah.
Yet the pilot ended up then having to coordinate 3 tugs that aren't needed. And I witnessed one occasion where the tug and ship actually made contact to each other. You can call it a collision or you can call it something else. But this is one good example where we actually call on resources that are not needed just because we can't determine always. So we need better methods of doing that. We need flexibility, and we need to be able to be really, really agile and to change fast. And we're not good at that in maritime yet. At least that's my experience.
No, and that's one of the observations. So thank you for that, because it goes to your social redundancy. By adding an additional resource in, you upset the system, and you don't know how the system will adapt necessarily to an additional resource, as it may confuse the activity rather than simplify it.
Yeah, that's exactly what my experience is.
Good.
Just before we go to a next question, and it may come back to you, Robert, Phil Helmore is just asking, could you just repeat the 3 different domains of human factors engineering for us? You talked about ergonomic, cognitive, and
organizational.
Organization. Thanks. So, other questions? I didn't want to cut you off, Robert, if you had something else to follow.
Not really, other than from experience, from what I've seen I do a number of safety investigations into incidents, generally in the workplace, and it's what I see so much of is the difference between work as imagined and work as actually done. And I think from a design of work principle, I think whether Joachim, you've got any ideas about this, but designing work that allows variability, and you set upper and lower control limits for the variability of how work is done, and allow that inherent variability and not get concerned about it, except when it starts to approach those upper or lower control limits, for example. And that's when you put in a response to bring the system back under in more in control. Is that something that sounds sensible to you?
Yeah, and I've started using another of Holnagel's techniques called the resilience assessment grid, where he looked at 4 potentials. To be able to deal with variability, you need the ability to monitor the system and detect when you need to respond.
Yeah.
Secondly, you need the ability to respond fast and powerful. You need the ability to anticipate. You need the ability to learn. So I guess the monitor and respond there are key things. And just from my experience, taking the same example with tugs, one issue was that you had to book tugs 2 hours in advance, and if the weather was bad, you might book a tug, but then the weather changed within those 2 hours. You still have to pay for that tug, so you take the tug even though you don't need it, and you end up with a coordination problem. Social redundancy. What we're looking at now, or hopefully what they're looking now, is that maybe removing that 2 hour booking period to make us more responsive and faster. So those things of redesigning the system to make us more agile and less viscous as an organization.
Might that lead us to something like what happens with car accidents and the tow trucks who are sort of milling around waiting for the next one to grab? So you've got all of these tugs waiting, who's going to get the job?
Concept.
Yes, I found it fascinating, some of the comments, the work imagined versus the work done. I guess as an academic and trying to plan courses and engagement with students, you think or you imagine that they're going to be so excited to do this stuff, and they'll read this, do the pre-reading, and they'll come prepared. And so many times that doesn't happen the way that you would ideally like it. And we've got to adjust. And certainly this year with COVID has challenged all of us, I think, in how we do business as a whole and what's appropriate. So many people now are discovering that they can work effectively and efficiently, and maybe too effectively from home. And we are being asked to do not just 25% extra, but even more because we can.
Yeah, and I think the other thing is, Jochen probably has this, and this is probably an outcome with social redundancy, is that, and the design of our interaction between the human and the system or the technical system is making sure that people maintain their interest and still have a sense of value that's acquired out of the task. Because if there's a reduction in the sense of value that somebody's getting out of their task, that's from my observation, that's a way that leads to loss of engagement, and that's when people zone out and accidents are more likely to happen.
Yeah, and coming back to the first question we had about the computers and humans and double recounting the calculations they do. I know in aviation they come over this with autopilot has just made the pilots losing a lot of their skills. So they're now removing autopilots from some parts of some flights and so on, just to make sure that the people are actually skilled, maintaining their skills and maintaining their abilities. We just need to be smart and think of new things of dealing with these things.
So could you characterize perhaps what the primary findings or contributions were that stem from your PhD work then as an extension of these ideas?
I think stop talking about components of a system and what Robert said, start talking more about function of the system, functions, and doesn't matter too much about what component is going to perform that function. And sometimes it might be one component, other times it might be 2 components, other times it might be 3.5. But the function is what's important, not which components do which and what. And in maritime, at least in in my field of maritime, we're so married to this old concept of having a shipmaster, a pilot, and a VTS operator and tugs. Maybe we should start talking a little bit about what actually are we trying to achieve. Sometimes we might need all of them, sometimes not. We need to just be shifting our view towards the function rather than the person or component or technical thing.
Or coming back to that safety case idea of not one set of regulations covers everyone, not trying to force everyone to do it exactly the same way. If they have got bow thrusters, if they have got their own manoeuvring capability, then let them do it. You don't have to go by the old rules.
Exactly. I mean, this is where the response to some of the oil tanker disasters. We have a trailing tug or whatever, and we, because of a vessel is a certain gross tonnage, we apply those particular rules. Whereas obviously a bulk carrier or VLCC is its maneuverability is an incredibly different capabilities compared to, say, a cruise ship.
I think and regulation here plays an important role because they are so much shaping what we do. Yeah. And I think we're starting to see some change here. For example, in a lot of countries in Scandinavia, they changed from pilotage for all vessels over 70 meters to risk-based pilotage or something like that, where the vessel actually has to prove they meet certain criteria, and if they do, they don't have to take the pilot. That under certain circumstances, in certain conditions, just a more allowing for the variability.
Can I invite any other questions from anyone else? Please unmute your mic and come forward.
I just wanted to say, to find out how the work is actually done, you have to monitor the system after you've built and handed it over, which we often don't get an opportunity to actually do. So
I didn't really hear you.
To find out how the work is actually done, you need to monitor the system after you've designed and built and handed it over. And we don't always get that opportunity. In my job, for example, we might write a trim and stability book, and we'd have all the intentions that all these specific things are done. But in reality, when you go and do an inclining and you find out, oh, we don't have a copy of that floating computer, or there's always something that's, we load all our cargo in this location, not that location, and it's very difficult to have a really good idea of how the work is done until you've gone and inspected it yourself and spoken to everyone.
Yeah, I can just encourage, I know it's easier said than done, but to get out in the field more, and also to embrace more almost ethnographic studies in engineering, so that we can actually learn what goes out when they build the vessel and when they use the vessel. It doesn't have to be big studies, but just those field, so we actually get some field experience and get to see that and get to interact with those people, and vice versa. Extremely important.
Yeah,
but
there's incredible value in that, because I, as part of my job, go out and incline Navy vessels, and therefore you get to interact with all the people who are using the trim and stability book that you write, and it's amazing the things you learn that they're doing or not doing. So yeah, it's a very valuable, but not much can be done from the office.
It's about feedback, isn't it? And engaging everyone in the process such that, and I think we had this discussion recently in another meeting that Rob Galing was presenting, is, what do we think about in design? And a number of us might wear at some point in our career a label that says we're the designer, but really everyone's got a role to play in design, whether you're making comments on what 1 or 2 or 10 of the requirements should be, or you're providing feedback on what's worked in the past that would influence it. You're having design input. And I guess what you're saying there, Joachim, is that we should be looking for ways to engage everyone that connects with the system and gain their feedback as to how improvements can be made, and not just sort of structure it as one way. So looking for options, but also looking for, as you said, that agile approach to maintaining safety. But you know, the issue was interesting around efficiency and thoroughness, or safety and quality versus output. I'm not sure I like the idea of the 2 forklifts, one lifting the other, but we see so many silly attempts, and you know, we hear about the ones that go wrong, but perhaps not the thousands that we should hear about that would change behaviours. Very interesting.
Yeah, another good reason to actually get out and watch things, how they work without them going wrong. What kind of silly things are done under normal performance? Once we've seen that, that might change the way we think about it. And what they do when things go wrong might not seem as silly. It might be exactly the same thing they do when things go right.
And I think that's some of the work that's come out of Professor Holnagel and a few other of the safety designers and safety leaders. There's that, you know, it's, you know, the work can be done consistently in a not in accordance with a plan or design. And, you know, 99 or more times out of 100 or whatever, it'll be done successfully. But then on one occasion, for some reason, it doesn't. And just to your point about getting out and observing stuff, I actually started off as a shipwright, and the standard joke was, you know, for heaven's sake, don't trust the design of a naval architect, because you're not going to be able to get your welding torch into a certain place because they've never thought about how you're going to weld it up. And, you know, I've been in situations where welders have used mirrors to weld, you know, to do welds. So I think it's whether we're designing a soft system or a hard system or a structure or whatever, it's actually getting out and understanding what the actual environmental structure that the thing is going to live in, and then we that can be that'll help inform us as we design the system or the solution, and hopefully reduce the variability between work as imagined and work as done.
Thanks, Robert. Any other comments, thoughts from others who have otherwise been silent? Trying to generate a bit of a discussion here, so don't be bashful.
And I just want to apologise for maligning naval architects. I didn't mean it that way.
That's all right. No offence taken. We've all got lessons to learn from one another. We don't.
Isn't that a
none of us
blessing?
get it all right every time.
Exactly. Isn't that a blessing?
Mike is shut off. Yeah.
Any? Yes, Ravi.
I've with the work as imagined as work as done, which is very interesting. That I've been conducting a BRM course for the last 25 years. And in the last 3 years, we made more progress than the previous 22. Because for the first time ever, we actually have data. You know, because we suddenly discovered in 2016, 17 actually, the end of 2017, that for the last 3 years, nearly every accident report had been based on evidence from voice data recorders, from actually recorded evidence. But prior to that, it used to be all witness statements, and they are notoriously unreliable. And we actually got a picture of what really actually happened on the bridge of a ship. And so in aviation, they've had this advantage over other industries that they've had recorders since '68. They got a reasonably good idea. And then there was another initiative that they had in about 1990. There was just before that, there was an accident in Canada where a plane took off without de-icing the wings. And it's a place called Dryden in Ontario. And that resulted in major changes in the aviation industry. Previously, you just blamed the operator, and that was the end of it. So a systems approach was introduced. But more significant than that, James Reason at that time, he was one of the expert witnesses, and he said that it's impossible to eliminate human error, and it's better to put your effort into managing it. So the corollary of that is, if you accept that, then what happens is that you have to know where the errors, as just mentioned about where the errors actually occur in normal operations. So the aviation industry did it by three ways. One is self-reporting. So in aviation, it's just a normal thing. A person makes a mistake, he reports it. In shipping, we've got this history, this huge baggage we have, where error is associated with incompetence. And also there's the Admiral Byng factor. Admiral Byng was shot in 1757 for not doing his utmost. People actually think he was shot for cowardice. It's completely wrong. You look it up. He was shot for not doing his utmost. So making an error, like putting the helm the wrong way, which happens very often, at least once a pilotage almost, it happens where the helm is put the wrong way. And that's trivial compared to doing your utmost, where a person was shot for that. And that's why I believe in the UK they keep on about the human element and things like that. They avoid using the term human factors. So the thing is that once you got this data, so now in shipping we're faced with this problem. Sorry, 1 minute ago I lost my way a bit. So the three methods that they have is, one is self-reporting. The second one is a thing called LOSA, where specially trained people go into the cockpit and, like a fly in the wall, they note the number of mistakes made. And that's how we know that an average of 3 mistakes are made on a Qantas flight. So in a week, there's thousands of errors, but there's no planes falling out of the sky because they know where the errors occur. And the third one is data links. And what we've got in shipping now is data links. We haven't gone through the first two, but there's data links now from, the shipping has entered the age of big data. There's a steady stream from the CCTV cameras, from all the sensors on board that are going to the head office. They stop at the pilotage. They haven't gone into the pilotage, but it's only a matter of time that that's also going to be included. So we're really at a time when there could be a very major shakeup of the whole system. So because we didn't know what went on, there was a ship, the Costco Busan, that hit the bridge in San Francisco and spilled a lot of oil. The pilot got 10 months in jail as a result of that, because spilling oil is a strict liability offense. There's no defense against it. And if you're prosecuted under that, you're going to get a person will get a jail sentence. And so this pilot's sole technique, because it was just left entirely up to the person, his sole technique for passing under the bridge was to put the variable range marker on his on the radar at 0.35 of nautical mile, and then he would do the kind of crude parallel indexing, and he would pass under the bridge with that. After the event, everybody jumped up and down. There was, and the bridge that he hit, 280,000 vehicles use it every day. So
yeah, hindsight's 2020, isn't it? But
yeah, so shipping has always relied on hindsight, and now what's happened is suddenly we've been thrust into this age of big data. And I've come out of semi-retirement now to conduct courses, and I use a lot of human factors in my work, because for the first time, even between day and night, I'm pretty certain in the Navy they don't differentiate between day and night. That's human factors 101 in aviation, because human beings are not designed to, haven't evolved to work at night. Outside aviation, there's a huge amount of work to be done. So I don't know if there's anybody from the Navy here. They don't. I'm pretty certain they don't differentiate between day and night operations. We showed an accident report to a person from the aviation industry. He completely rubbished the report written by one of our investigators. He said there's no mention that it's at night. And for night, and if it's at night time, and that Norwegian Helge Ingestad in Norway, that would have never ever occurred during the day, where they mistook, and there's a loss of $1 billion. And even now, they've so in maritime, it's very difficult because of the, I don't know, the culture and the baggage from the past to actually integrate human factors thinking. While in aviation, there's some level of human factor, the baseline, the guys who fix the aeroplanes, they've also done a human factor. Everyone's done it. The management has done human factors courses. And that's what my experience, I've got a lot of help from Qantas over the years. And this is the big issue, is how do you get human factors, some kind of basic knowledge of human factors into other professions? And I really feel this very important. And this is after 25 years of bashing my head against this in maritime. We have made progress in Australia in marine pilotage and other areas, but this is the big thing. How do you get human factors? Sometimes I feel it should be taught in schools at some level. Because at every level in aviation, they do a subject called human performance and limitations, whether it's recreational or it's commercial flying. So maybe there should be something in naval architecture, in not just a bit of add-on, something substantial in there.
Yep. No, I agree with you. And all of these systems, at some point, we interface with them in some way. And perhaps that's not considered, or it's thought idealistic. We talk about our fluids mechanics problems, and think about an ideal fluid with zero viscosity and what might happen. Perhaps we do the same thing, thinking that people are going to behave as robots with exactly the same behavior, whether they've had any sleep for the last 16 hours or not.
Warren, are you going to include something on this in the new Naval Architecture degree program at ADFA?
Well, it's quite possible in the new program we're standing up that there'll be at least something that talks about and draws attention to this issue.
Well, Joaquim, your presentation.
Yeah, just as an example, the ECDIS on a ship is being designed by a whole lot of committees, right? And so after the U.S. naval ship, the naval ships have also got a form of ECDIS, a more bulletproof form of an ECDIS. That's electronic chart ECDIS, and so what's happened is they're now all surface fleet ships in the U.S. Navy are being supplied with PPUs. That's what the pilots carry, because they're not user friendly. The ECDIS is not user friendly at all. It's very complicated. And the PPU, one glance at it, you can see what the ship is doing. So
there's new technologies coming along. I guess we asked the Warby team who presented to us last week about how they measured distance and speed as they attempt to break or build to breaking a world speed record. And they said GPS. Well, we wouldn't have thought of that X years ago, and there's always this new technology. So as you say, maybe the ECDIS is to too complicated, and we need to adopt simpler systems in everyone's hand.
Some human factors principles to it. We wouldn't have reached the stage where now the US Navy, they've got actresses on the ships, so are naval ships, but they are now getting these portable pilot units because with one glance you can see exactly what's going on.
Yep. We're coming up on, or we're past 7:30. Any questions or comments from anyone else?
Hi, Joachim. I had a question when you spoke about reviewing pilotage. I sort of got some similar feedback when I was working overseas with some contractors that had previously taken vessels down into Australia. And one of the things of the rules when entering Australian waters is to have a minimum amount of Australian crew. And with that human factor, they were saying that they then had to take experienced crew that were familiar with the vessel, how to operate the machinery and the systems and that end function off based on this rule, and the kind of safety implications of that and the kind of efficiency as well. When I found it interesting when you were talking about thoroughness versus efficiency. Yeah, I think it's an interesting one, and we're one of the few countries that does it. So, yeah.
Yeah, it's interesting, and it really shows that we can't view a system in isolation. We really have to take into consideration regulation, politics, culture, work protection action, unions, and all of those things to really understand the performance of the system. I guess it's whether we're in Australia or elsewhere. Yeah, I haven't really observed anything in relation exactly to that, but I can really see I've really did capture some really good data and good observations where influences where they were least expected really just turned everything upside down in a moment.
Yeah, there's so many cases, I guess, with different things. You try to make a step forward, and the unintended consequence of one action causing a whole stream of problems somewhere else that you didn't predict. So somehow we need techniques or better ways to think about those risks and that knock-on effect.
Absolutely, yeah, for sure. We need better toolbox to deal with this rapid changes and frequent changes. And coming back to the ECDIS is just a very good example. In 96 or early 90s when it was developed, we thought that we could invest in a piece of computer that would last us 15 years without any update. And then came iPads, and then came everything else. And now you can't hold on to anything like that for more than 2 years, and then it's obsolete almost. And now we see pilots using iPads that are really to a lesser standard than an ECDIS, but the usability is much, much higher. We can't be as rigid as we has been in the past to deal with the variability of the future of today.
Okay, well, last chance at City Prices if someone would like to raise a question or make a comment. I won't run it like an auction, but sort of almost going.
I just want to thank Joachim for a very interesting presentation.
Thanks, Ravi. Yes, I was going to do exactly that. And thank you very much, Joachim, for your time and your commitment to the group. Please note that there will be a small gift voucher coming your way. Lily's got that all organised, so thank you, Lily. But thank you very much, Joachim, for your time and contribution today. I think you've made us all think a bit outside of where a lot of us perhaps would normally be thinking. If you said to me, what was ergonomics? Yeah, I'm worrying about how high my monitor should be so that I'm not creating a problem for my back or neck. But this idea, as you said, for HFES, of really focusing on interactions of humans in systems, sort of broadens that concept of human factor. It's not just what is the ship doing to my stomach, but what's it doing to everyone's, and how are we then still going to manage to keep the ship going the direction it's supposed to. So we invite you to join Rainer. It's a broad forum of not only naval architects but mariners in that maritime domain. But thank you very much.